All right, hey, so we've got a child throws a ball straight up in the air. The ball's to reach at 9.8 meters. What is the minimum initial velocity that it must be imparted? And it started from 1 meter, okay? And so S of t is going to be your distance traveled. The acceleration is a negative 9.8 because you're talking about gravity here. Then if I take the the integral of acceleration, I get the velocity function, okay? And then if v of 0, okay, if I, basically if I set v of I'm trying to find the velocity at 0, and it turns out that it's going to be the initial velocity, VO, right? So v of 0 is the initial velocity. If I solve for all that, then this constant of differential integration is the initial velocity, okay? All right, so now that that's said, I'd like to find the time when the velocity is 0, okay? So, well, remember, the kid threw the ball up, so it has an initial velocity, and at the top, at the maximum height, the velocity is 0 for a moment. So if I take this velocity formula here, and I make the velocity equal to 0, and I ask the equation to give me a time, then I solve for time. I'm going to subtract a VO and divide by a negative 9.8. And so my time at which the velocity is 0 is at the initial velocity divided by 9.8. And I unfortunately don't know that time right now, but that's okay. I'm going to keep it in mind. All right. So I've got a lot of information here. My C0, my C1 is my initial velocity. And I know that my initial velocity, I know this. Now, taking a look over here, if I integrate my velocity function, I get my position function, okay? Remembering that C1 is 0, and then I've got another constant of integration, which is C2, okay? Remember, my C2 is 1 because my initial position is 1, and so I'm going to actually put that right there because remember, this is actually going to be your initial position, okay? Because if I evaluate S at 0, all these terms go away, and this is the initial position. Remember up here, it said that the ball was thrown from 1 meter. So that's where that 1 comes from. And now here I've got this formula, okay? Now the idea is I'm going to go ahead and I want to find when the position is 9.8. So I'm taking S of t and setting it to 9.8, all right? And I actually know when that happens. It's at the top. Okay. Well, the velocity at the top of the at the highest point, the maximum is 0, and I know the time is here. So I take that time and I plug it into here. That time corresponds to when the ball is at the top, and this height corresponds to the height when the ball is at the top. I take this and I go ahead and I solve for the velocity, okay? And that's just a bunch of algebra from here down, and you end up with 13.113, something like the by the way, you can actually use physics energy to solve this in basically one step. So it's kind of funny if you do it with calculus and differential equations. It's actually a bit of a bear. But if you do it with physics, you can actually do it in virtually no time at all. So anyway, that's kind of a fun little thing.